Welcome back to the next lesson in our toothbrush project, in which we want to generate a low poly and a high poly version of this toothbrush to bring it to an external painting application, in my case Substance Painter, but you also can use Mari or 3D Code. And we also need UVs on the brush, so let's get started. And the first thing I want to show you here is that I have made a little change. You see here I have an additional edit node here added in my tree, and the reason for this is really easy to see. If I deactivate this by bypassing it and I press the plus sign here on my keyboard to show the viewport subdivisions, you see that this shape here doesn't fit too much this here, and I wanted to change a little bit the whole thing. And what I've done is I've added the edit node, and then I moved here some points around to have a little bit more of this edge here. That's all I've done here. And that's the cool thing in a procedural tree here, that you can change every edit node here if you want, or a little bit of the radius and so on. And this is not a procedural modeling approach which I teach here. This is direct modeling. If you are really interested in procedural modeling, please let me know and I do something like that. But in these Houdini practice hours I do here, it's the direct modeling approach. So you have to be careful, but it works fine if you go here and move points around and so on. So the next step I normally now do is I want to subdivide this a little bit more because I need some polygons to work with. So I modeled it low poly, but this is too low. So I add now a subdivide node here into my tree. And I use here Catmull Clark, that's great. So I have a depth of 1, that's absolutely enough. And now you see this topology here. You have seen that through my approach, which I've done with extruding only and beveling only these outer edges, I was really careful not to produce any triangles in this mesh, because in the rendering process, and if you go really close later, you want to subdivide in the renderer much more, and triangles will always break your stuff. So try to work with quads as long as you can, and now you see this here works fine. So the next step now is I need UVs for this toothbrush because I want to paint on the surface, and for this we need UVs. And in the last Houdini practice hour we had this banana and we looked into UV flatten and how to set seams and so on. And so this time I wanted to show you a faster way, and for this we used the Side Effects Labs shelf. Side Effects Labs is the new name of the game shelf. And the programmers of that at Side Effects decided that there are so many tools now in this Side Effects Labs environment which are so useful outside of the game world that they rename it. So Side Effects Labs is really something you have to install. The cool thing is, if you install Houdini, never heard of that Side Effects Labs, you can go here to the shelves and search for Side Effects Labs here. Here it is, activate this shelf, and then you click here Update Toolset. And then you see everything works now like a charm. It says, okay, you have this version, the production build is this version, you update. After the updating, restart your Houdini, everything is fine. And I think there's also here now under window, a new item here which you also can use. And beside of these shelf tools here, we have in different contexts different tools. So it really depends on the context. If you are in this scene view here, let me jump out here, press the tab key, you see here under labs only 3 tools. If you go into our brush, into a container, so you are now in the subworld, and you press here the tab key and go to labs, you see a whole bunch of extremely cool tools. And they are so fast in developing, so thanks guys for these great tools. If you want to learn more how these tools work, you can go to the Side Effects Labs webpage, which you find from the Side Effects website. There's a path to this, or you can ask me and I can make some tutorials about some of these tools. So we use some of them now, and one of the really useful tools is the Auto UV. So let's go in and say Auto UV. You see Labs Auto UV as a beta. You add this, and now we can insert this here because we always want to use UVs. Set your display flag, go with spacebar 5 into the UVs, and you see, wow, that's done. We can check here really fast to the display here, the distortions. You see it's not so distorted. Also, we don't have any overlaps because it's a really easy shape, but you can test it here. Or you can use spacebar 1, we go back, another labs tool, which is named UV Visualizer. Here, labs UV Visualize. And if you test this now, you see here now our grid on the surface. We can change the grid tiling here to make them bigger. And you see it looks good from my taste. You see here the seam. If you want to see the seam more obvious, we can activate it here, Visualize Seams. And because this here is really small, I have to make here the value a little bit smaller. Yeah, and now you see these are the seams. For my case, because we want to work in Substance Painter, everything is okay, but you also can manipulate the seams if you like, or do it the classic way like I've shown you in the other project. But what I want to do or try is I go back here and try, instead of ABF, maybe a spectral approach. Yeah, maybe that's nicer. And then we can get rid of the visualizer here. UVs are done. Great. If you now want to work external in Substance Painter, 3D Code, Mari, and so on, you normally need a whole bunch of maps so that you can work intelligent. You need a curvature map, a position map. You want to have maybe nice normals, because these normals here are only interpolation of the polygons which we have, and so on. And for this we normally use bakers. And you find in most of these tools bakers, or you can use external bakers, for example in Marmoset or Xnormal and so on. But the game shelf also has a baker. So if you go here and type in baker, you see here a labs baker. But I want to show you how to bake in Substance Painter, but if you're interested in baking directly inside of Houdini, so this is the right node, and you can look up tutorials for this baker here, or ask me in the comments if you like, so that I explain you how this baker works. To work with the baker, you normally need a low poly object with UVs, which we have done, and a high poly object. And so we have to generate now a high poly object. So let's do that. We say here, this brush here is our low poly version of the brush. Okay, done. And then we want to generate a high poly mesh. And I normally do that by making a volume out of this. The big advantage with this is we have really cool smoothing tools for the edges. Sometimes a volume is also really useful that you want to add, for example, noises and so on, because you want to have a little bit more details on the surface, so you can go a sculpting approach with the help of procedural noises and so on. Or maybe you want to use here cutting techniques or so, which are really good in volumes. Labs has a tool for this, so it's named Labs Voxel Mesh here. You can use this directly, but I want to show you the way doing this by hand, which I normally do in production. So let's start here with the VDB node. And the VDB world is really fast and really flexible, so I like the VDB nodes inside of Houdini a lot. And we use a VDB from polygons here. And we add that here. And if you click now here, this is the result. Now we are in the volumes world. But this toothbrush looks terrible because we only have 873 voxels. If the name voxel doesn't sound something which you know, maybe you can take a look into my Houdini fundamentals training, where I have a whole chapter for volume nodes inside of Houdini. But fast explanation is a volume is built out of voxels, and you can understand a voxel like a three-dimensional pixel for an image, for example. And if you have very few voxels, you get a really jaggy result. If you increase the amount of voxels, you get a better result. It's the same like in an image program. So if you have more pixels, you get a better image. And the same is here. So the amount of voxels you can set here with the voxel size. The voxels are 10 centimeters in the moment, and that's the reason why we have only here these 800 voxels. If you lower now the size of the voxels, you see it gets better and better. And because we have time, because we do it only once here in the whole process, I make them really small. And now you see we have 3 million voxels here, and you get a really nice surface. You still see here a little bit the polygon structure. The reason for this is that these voxels really show the polygon structure. So there's no normal faking surface. So it's really the original structure. To now make this smooth, we can use a VDB node. And we have 2 VDB smooth nodes, one smooth and one for sign distance fields, which we want to use in our case. And if you add this here, it takes a while, and then you see it's a little bit smoother. The VDB smooth works like a Gaussian filter inside, for example, Affinity or Photoshop. It takes neighboring pixels and interpolates them. And how many neighbors it looks is set here in the voxel radius. So one neighbor to the left, one to the right, one to the top, and so on. And this value here depends on the resolution you had here. So for such a dense voxel mesh, one voxel is not enough. So you can say, ask always 2 neighbors, for example, and you see it's a little bit more soft here. If you have really low voxels, 2 will be too much. Next step is we can now smooth this more than one time, and these are the iterations here. How many times you want to run this smoothing process. So let's try something else. I make my voxels a little bit bigger. Okay, a little bit smaller. And then you see it looks much, much better, because now with this amount of voxels, 2 voxel neighbors works fine, and then you can tell, okay, how often you want to walk over the surface. But be aware, you see your object shrinks at this point because you smooth it. So be careful with that. Let's go 1 down and only make it, for example, 2 times. Okay, something like that. Let's compare these two. I think it's okay for my taste. Yeah, it's nice. And if you want to give it a little bit more flashback because it has shrunken, there are VDB nodes for this. For example, reshape SDF here. And in this here, you can now say you can erode, so make it smaller, or delete, make it bigger. And so you can go in here and say, yeah, make it a little bit bigger again. You have to be careful about that, how much you do. But yeah, it's possible. Let's take 1 and see what happens. Yeah, now you see, oops, not B, bypass it here. Yeah, you can do that, but I don't think that we run into a problem here. So I think that's absolutely okay what we have done here. So bring it back, VDB, convert, and activate this. And don't forget, after VDB convert, you have a Houdini volume, but still a volume. You see here, it's still a volume. You have to switch here from convert to volume to convert back to polygons. And this here is now our result for the high poly mesh. So this is the original, and this is our high poly mesh. And these two we use later now for baking. So make a null here. Say this is the high poly mesh. And now we can write these two out. So let's take a ROP. ROP stands for render output operators, and we take FBX because this is really flexible for us. So take a FBX here. We go here, say we want to have it in the job from Houdini. This here is now our high poly brush. You see I've done this before, not as ASCII. And then we say save it to disk. Then we need another ROP here. Low poly mesh job from Houdini, low poly brush, FBX, not as ASCII, render current frame. save to disk. And that's it. And now we have both objects out on your hard drive, and now you can start working in your 3D painting application. This ends the first chunk of this second project, Toothbrush. I hope you learned something and you had fun with that. We see each other next week for the next chunk. And if you have any comments, wishes for tutorials or areas of Houdini which you want to see, please write this in the comments. I am happy to help. Also, if you like it, subscribe please my YouTube channel, give a thumbs up because it's much work to do that. My name is Helge Maus from Pixel Train. See you next week. Have fun.